Hello, today I'll be going the 2025 F equals to ma problem 6. So this problem is about a ball that is slipping down a ramp, which turns horizontal at the bottom. At the bottom of the ramp, the ball falls through the air as shown in the diagram below. If the ball starts from the position marked as O, it lands 10 centimeters away from the bottom of the ramp. Which starting position will get the ball to land closest to 25 centimeters away? Okay, so today we'll be looking at some of the relationships between energy, and we'll also be seeing how the incline won't actually affect this answer. Let's dive in. Okay, so let the height equals to kh. So what do I mean by this? The height from O would be equal to 1 times h, as shown here, see? The height from A equals to 2 times h, as shown here. Because all of these points are equally spaced, by the concept of similar triangles, which you might be familiar with from math or just scaling it up and some symmetry, we can tell that the further the distance is from this central point at which the inflection point happens, it will be a scaled up version of h. So O will have a distance of h, A will have a distance of 2h, B will have a distance of 3h, and so on and so forth. We want to find the appropriate value k, which constitutes to each of one of these points, so that our range will be 25 centimeters, given that when rowing from O, it will already land at 10 centimeters away. How are we going to do this? Well, we can apply the law of conservation of energy. As there is no friction on this ramp, the ball will not be losing any energy as it goes on. Basically, its potential energy will be constantly being converted to kinetic energy to give our final velocity when it finally leaves the ramp. Okay, so since it's at a height kh at the beginning, its original potential energy would be equal to mg times kh. Meanwhile, its kinetic energy would be equal to half mv squared, where v is the velocity when the ball is leaving the ramp, as in when it's flying up. Notice that's perfectly horizontal, which will play an important role later in the problem. So when we analyze this equation, we get that 2gkh equals to v squared. Now that we know what v is in terms of k, because after all, h, g, these will all be given constants, right? We need to find what the range is with respect to v. So notice that while gravity will be pulling down the ball as it falls off the ramp, its horizontal constant will never be changing, as gravity is a purely vertical movement. So therefore, v times the amount of time should be the range at which the ball is moving. So really what we need to know is how much time will the ball remain in the air. The amount of time the ball will remain by the air can be constituted by this equation, which constitutes as S equals to ut plus half at squared, which is one of the basic equations in speed in physics. In this case, the original velocity will be u, as we're looking purely at the vertical direction, and while it does have a horizontal component of v, its vertical component will be 0, so u is equal to 0 originally. Meanwhile, a is equal to g, as we're going to be assuming that the downward direction is positive, so we end up getting the s, which in this case I've taken as this height h, is equal to 0 plus half gt squared, implying that t equals to square root of 2h over g. Now, from both of these equations, we can find the range in terms of this value k. It will take the form of square root of 2h over g times square root of 2gkh. After all, we know that 2hg and 2 uppercase h, g, lowercase, these are all constants, so we can just say that this is all some constant. So this symbol means proportionality. This signifies then that k is proportional to the square root of k, or r squared is proportional to k. Or that r squared equals to some constant times k, if you haven't seen this notation before. Okay, now that we know this information, how can we use it? It's already given that at the given height of h, which means k equals to 1, r will be equal to 10 centimeters. So this means that 10 squared over 1 would be some constant. And that same constant should be equal to 25 squared over whatever k, whichever scaled up version we're looking at, must be the same. If we analyze this equation, we get that k is equal to 6.25, but after all, since these are whole number markings and they're asking for the closest point, we'd have to look at the k that's around 6, that has it around a height of around 6h. Since this is h, 2h, 3h, 4h, 5h, 6h, our answer should therefore be E. Thank you.